Let's take a look at this example. First, we have to find voltage source. What we're supposed to do? We're supposed to realize that we are dealing with the parallel circuit. So, voltage source is equal voltage across the resistor. This is equal voltage across the inductor, and this is also equal voltage across the capacitor. And let's check how much this is going to be equal. Please notice that we have given resistance and current which goes through the resistor. So I know that VR is equal IR times R, where IR is equal 20 milliamps times 5 kiloohms. This is equal 100 volts. So this is the voltage across each component, and this is also voltage source. So this is 100 volts. Next, we're supposed to find Z total. Z total equals voltage source over I total, where voltage source we found is equal 100 volts over I total 40 milliamps. This is equal 2.5 kiloohms. But please notice that we do not have angle. We have to find the angle. So in order to do so, we're supposed to use the formula for power factor, which is equal cosine of angle theta, and this is equal Z total over resistance. We're supposed to use just this part of the formula and solve this formula for theta. Theta is equal inverse cosine Z total over R. This is equal inverse cosine Z total we found is equal 2.5 kiloohms over R, which is equal 5 kiloohms. This is equal 60 degrees. Please notice that we do not have given extra information which reactance is going to be greater, X of L or X of C. So at this moment, I'm going to assume that angle has to be positive. So let's do the assumption, and later on we are going to see if this assumption was correct or not. So I can write that Z total is equal 2.5 kiloohms and angle of 60 degrees. Okay, so this is my Z total. Next, I'm supposed to find the current which goes through the capacitor and current which goes through the inductor. So we have found the voltage source, which is also equal voltage across the capacitor, and we have X of C given. That's why I can find very easy IC. IC is equal voltage across the capacitor divided by X of C. This is equal 100 volts over X of C, 10 kiloohms, and don't forget that X of C goes always with angle negative 90 degrees. This is equal 10 milliamps and angle of 90 degrees. Okay, so this is the current which will go through the capacitor. Next, we're supposed to find the current which goes through the inductor. In order to do so, we're supposed to find the angle for I total. I total is equal voltage source over Z total. Voltage source has angle 0 degrees, and Z total we found has angle of 60 degrees. Okay, so this is equal, I total is equal what, 40 milliamps. Supposed to copy down the magnitude of I total, and anytime we divide the polar forms, we're supposed to subtract the angles. So I'm going to have angle negative 60 degrees. 0 minus 60 give me negative 60 degrees. And this is basically my total current. Next, we're supposed to use KCL. KCL says that anytime we have parallel circuit, and if you are going to add all the currents, I mean IR, IL, and IC, you're supposed to end up with the total current. So I have I total is equal IR plus IL plus IC. If you are going to solve this formula for IL, you are going to obtain IL is equal I total minus IR and minus IC is equal, I total is equal 40 milliamps, an angle of negative 60 degrees, minus IR, which is equal 20 milliamps. This current is given, minus IC, 10 milliamps, an angle of 90 degrees. This is equal 44.64 milliamps, an angle of negative 90 degrees. So if you are going to get angle of negative 90 degrees, so it means that your calculations are okay, because IL supposed to be with angle of negative 90 degrees. Okay, so I found IL. So next we're supposed to find X of L. I'm going to find this over here. X of L is equal VL over IL, where VL we said is equal 100 volts over IL we just found is equal 44.64 milliamps, an angle of negative 90 degrees. This is equal 2.24 kilo ohms, an angle of 90 degrees. Okay, so this is the value of X of L. Next, we are going to find the power factor. Power factor is equal cosine of angle theta. Cosine, in this case, angle which is next to Z total, right? Magnitude of the Z total. So this is cosine of 60 degrees is equal 0.5, and I'm supposed to write word lag. Why lag? Because the angle is positive. Okay? If I have angle positive next to Z total, the current, the total current, is going to lag the voltage source by, in this case, angle of 60 degrees. Next, we are going to find the true power. True power, I'm going to write over here, true power is equal voltage across the resistor raised to the second power over resistance. So this is equal 100 volts raised to the second power over resistance, and resistance was equal 5 kilo ohms, right, is equal 2 watts. Okay, so this is the true power in my parallel RLC circuit. Now we're supposed to find the total reactive power. In order to find this power, I'm going to find first total reactance. XT is equal XL times XC over XL plus XC. I'm using the formula called product over the sum because inductor and capacitor are in parallel. Okay, so we have X of L is equal 2.24 kiloohms, an angle of 90 degrees, times X of C, 10 kiloohms, an angle of negative 90 degrees. Don't forget that X of C goes always with angle negative 90 degrees, over 2.24 kiloohms, an angle of 90 degrees, plus 10 kiloohms, an angle of negative 90 degrees. The answer is 2.88 kiloohms, right? An angle of 90 degrees. Okay? So please notice that X of L has lower value than X of C. So when X of L is less than X of C in the parallel circuit, the angle is going to be positive. Okay? If the angle is going to be positive from this calculation, right, for the inductor and capacitor, so the total impedance is going to have also positive angle. So please remind that our Z total is equal to 2.5 kiloohms and angle of 60 degrees. Remember, we were calculating the angle and we assume that the angle has to be positive, right? So it is good assumption, because if you'll get X of C, X total with the angle of 90 degrees, so it means that it was good assumption. If you would get, let's say, angle of negative 90 degrees, you're supposed to get back and fix this angle and redo the calculations one more time. So now we are ready to find the total reactive power. Q total is equal voltage source raised to the second power over XT. So I have voltage source raised to the second power, so this is going to be 100 volts raised to the second power over XT, 2.88 kiloohms, is equal 3.47 VAR, volt ampere reactive. And this is the total reactive power in my parallel circuit. Next, I'm supposed to find the values of the components in the series equivalent circuit. So what I'm supposed to do first, I have to write again Z total, and Z total is equal to 2.5 kiloohms and angle of 60 degrees, and convert polar form to the rectangular form. Okay, so you're supposed to obtain 1.25 kiloohms plus J 2.16 kiloohms, where the real part is your RS, and because I have plus J, so this is for sure inductor, so this is going to be X of LS. Okay, so we found the values of the resistance and inductive reactance to find the values of voltages across that component. Okay, so now I can redraw the circuit, right? I'm going to have resistor RS, and I have inductor, right, with the inductive reactance XLS equals 2.16 kilo ohms, and RS is equal 1.25 kilo ohms, and voltage source is equal 100 volts. Okay, so this is my series equivalent circuit. So voltage VRS is equal I total times RS. I total 40 milliamps and angle of negative 60 degrees times RS, which is 1.25 kilo ohms. This is equal 50 volts and angle of negative 60 degrees. Okay, so this is the voltage across my resistor in the series equivalent circuit. Next, I'm supposed to find the voltage VLS. This is nothing else, just I total times X of LS. I wrote I total, but you can also write IRS and ILS, because this is series circuit. So I total is equal to the current which goes through the resistor and is equal to the current which goes through the inductor. That's why you're not supposed to write IRS or ILS. You can simply write I total. And this is equal 40 milliamps and angle of negative 60 degrees times X of LS. We have 2.16 kilo ohms, but instead of J I'm going to write the angle 90 degrees, and this is equal VLS is equal 86.4 volts and angle of 30 degrees. Okay, so this is the voltage across the inductor. Now we are going to verify if our answers are correct. I'm going to use KVL in this case, which says that the sum of the voltage drops across these two components is supposed to give me voltage source. Okay, this is the Kirchhoff voltage law. So I have voltage source is equal VRS plus VLS. This is equal 50 volts and angle of negative 60 degrees plus 86.4 volts and angle of 30 degrees. This is equal 99.82 volts and angle of negative 0.058 degrees. So we can say that this is almost equal 100 volts and angle of 0 degrees. So we can say that up to this moment our calculations are correct. Now we can say that we are ready to find the true power and reactive power in the series equivalent circuit. So PS is equal I total square times RS, where I total is equal 40 milliamps raised to the second power times RS 1.25 kilo ohms. This is equal to watts. Let me remind you that in parallel circuit the true power was also equal to watts. So it means that so far so good. Next we're supposed to find the reactive power, right? So I have QS. We can say right now that this is QL because we know that this is inductor, is equal I total raised to the second power times X of Ls. This is equal 40 milliamps raised to the second power times XLS equals 2.16 kiloohms. So QS, or we can say QL, is equal 3.45 volt ampere reactive. Let me remind you that in the parallel circuit, Q total was equal 3.47 VAR. So as you can see, these two values are very close to each other. So it means that we solve the problem correctly.